Okay, today we're going to talk about solving systems of equation, and we're going to talk about two methods to solve systems of equation. First method is what's called the substitution method, and what you're going to do is you're going to take one of the two equations and you're going to solve for one of the variables, which means to isolate one variable by itself on one side, and then the other variable will go on the other side. So whichever has the x or y will be easier to isolate by itself. So we're going to take the second equation here, and we're going to solve that and isolate for x by itself. So we're going to add 5y on both sides because we're going to cancel that out, and then we're going to add that to the other side. So that will leave the x isolated by itself. And then on the other side, we got 9 plus 5y, but it's better to write the variable first. So that will be 5y plus 9. So once you get one variable by itself, we're going to take that and we're going to substitute into the other equation. Now, since x is equal to 5y plus 9, we're going to substitute. So when you see x in the other equation, we're going to substitute 5y plus 9 into the x there. So this is substituting into that equation. So it's going to be 2 and then put parentheses instead of x, put 5y plus 9, and then copy the rest. And you're going to solve this because now we only have one variable, in this case y, by itself. So we're going to solve for y alone. We're going to solve for y in this case, and then use that to solve for x later. So distribute this. So that would be 10y plus 18 plus 3y is equal to 5. And then you want to combine like terms here with the y. So 10y and 3y, add the coefficients, so they get 13y plus 18 is equal to 5. And then you're going to solve for y by subtracting 18 on both sides. And that will be 5 minus 18, which will be negative 13. And then divide by 13 to solve for y. So that cancels out, so you get 1y, which is just y equals negative 1. So y is equal to negative 1. So then once you find one of the variables, then you can go and substitute or plug it back into any of the original equations, or you can even plug into the new equation here, assuming that you did that correctly, right? So then you're going to substitute here, since the x is already by itself, so we're going to use that. And then substitute negative 1 into the y. And then when you solve this for x, that will give you negative 5 plus 9, which is going to be 4. So x is going to end up being 4. Y is going to end up being negative 1. So you put it together as an ordered pair with x first, and then y, which means that the solution is going to be 4 comma negative 1. And that's the location where these two lines, if you were to graph it, will intersect at location 4 comma negative 1. All right, so that's how you can use the substitution method to find the solution where the two lines would intersect if you were to graph it. Now, what would happen if some of the equations like this one, if they don't intersect, then you will have either no solution or infinitely many solution, right? So no solution would mean that these two lines are parallel. Infinitely many solution would mean that these two lines end up being the same line overlapping each other. So then how would you know that algebraically? Well, once again, you want to substitute. First step is to solve one of the two equations, isolate one of the variables. So we're going to isolate the y here by itself because that's by itself, so that'll be easier. So then you're going to add 2x to cancel that out, and then you're going to add 2x to the other side, which will mean that the y is equal to 6 plus 2x, or 2x plus 6. It's better to write the variable in the beginning. So then again, this means that the y is equal to 2x plus 6. So then you're going to substitute that into the other equation. When you see y there, you're going to substitute with 2x plus 6. So let me rewrite that with substituting. So be careful, put parentheses. Instead of y, you're going to put 2x plus 6 equals 5. And then you're going to solve now for x in this case. Now, when you distribute this, be careful, because when there's a negative or -2, you're distributing -2 to both of these. So that would be negative 4x, and then that would be negative 12. So something interesting happens here. When I try to solve for x and combine like terms, the 4x minus 4x, they cancel out. That's 0x or 0. So the x is gone, right? So that's something that's strange that will happen when you're looking at infinitely many solutions and no solutions. So then we have negative 12 is equal to 5. Well, that is not true, right? Negative 12 is obviously not equal to 5, which means that there is no solution in this case. So that means if you were to actually graph this, these two lines would actually be parallel lines. So then when would it be infinitely many solutions? Well, if you get two numbers at the end, all the variables canceled out. And when you get two numbers that are same, and it doesn't matter what the numbers are, as long as they're equal and same, then you will get infinitely many solutions. If they're different, no solutions. So that's how you can use the substitution method to solve systems of equations. Now, the second method I'm going to show you is what's called the combination method. And another name for this is also called the elimination method, because both names describe what we're doing here. We're going to combine the two equations together. And as we combine, we're trying to eliminate one of the two variables, right? So, and it doesn't matter whether you eliminate the x first or the y first. So you want to try to eliminate one of the variables that's easier to do. So then what that means is that when you look at the numbers here, you want to get the same number for the coefficient, either for the x or the y, and we want one of them to be positive, the other one to be negative, right? However, if you look at all these numbers here, they're not same right now. So then what you have to do is you have to change them by multiplying one of the equations, or sometimes you have to multiply both equations. So in this case, if I'm looking at the y here, I can get the top one to be 10y by multiplying by 2, and that will cancel out with the negative 10y. So what I'm going to do is I'm going to multiply everything on the top by positive 2. When I do that, I get negative 12x, positive 10y, and then don't forget to multiply the 4 as well. And then the bottom one, we don't need to change. Sometimes you have to multiply both, but in this case, we don't have to do that. So then that's going to stay the same. And then what we're going to do now is we're going to combine these two equations, which means we're going to add the like terms by combining two equations. And then what we're trying to do is we were trying to eliminate the y here, right? So the y, the 10y and negative 10y is 0y, so the y is gone. And then the negative 12 and positive 7 is going to be negative 5x. This is 0, so the y is gone, so you don't have to write the y again. And then the other side is also 0. And then you solve this for x by dividing by negative 5. So negative divided by negative is positive 1x, which is just x, and then that's going to be 0. So we were able to figure out x first in this case. So x is 0. Now you take that and you substitute into either of these two original equations, whichever is easier. And so they're about the same, so I'm going to substitute into the bottom one here. So that's going to be 7 times 0 minus 10y is equal to negative 8. 7 times 0 is 0, so that's gone. So you get negative 10y is equal to negative 8. And then you're trying to solve for y, so you divide by negative 10. And negative 10 divided by negative 10 is positive 1. 1y is just y. Negative divided by negative turns into positive. And then 8 over 10 can be reduced by dividing both top and the bottom by 2. So that's going to be 4 over 5. So y is 4 over 5. If you want to do decimal, that'll be 0.8. And so the solution is going to be x first, and then the y, 4 over 5, or 0.8. And that means if you were to graph these two equations, it's going to intersect at 0, comma, 4 over 5. So that's how you can find a solution using the combination method, or it's also called the elimination method. Now, what happens, just like before, with the infinitely many solution and no solution using combination method? So once again, you're trying to combine the two equations, and you're trying to eliminate either the x or the y. Now, the numbers are a little tricky here, so you want to kind of use the smaller numbers, right, which is easier to work with. So I'm looking at 6 and 8, and I know that the common multiple of 6 and 8 is 24. So I'm going to multiply the top one by 4, so that will be 24y here. And then the bottom one, however, if I multiply by 3, that will still be positive 24, but I want one of them to be negative. So I'm going to multiply this by negative 3. So I get negative 24y, which will cancel that out. So make sure you multiply everything by 4 on the top. So that's going to be negative 36x, positive 24y, and then you still have to multiply by 0. I mean, it's still going to be 0, but don't forget to distribute that as well. And then the bottom one, negative times negative is positive 36x, and then you'll see something strange here, negative 24y, and then that's still going to be 0, but you still have to distribute negative 3 times 0. And then notice, we were trying to eliminate y, and we did that, so the y is gone. But the x is also gone as well. So both x and y are gone. So you have 0 here, you have 0 here. So then you get a 0 on the left side. And then the right side is also 0. In this case, they're equal, they're true. Which means if two numbers are equal after all the variables canceled out, that means that's infinitely many solution. So that's how you can use combination method, or what's called the elimination method. And in this case, we were able to eliminate both variables, and then the numbers came out to be equal. And that's how you know that these two lines are going to be basically overlapping each other, same line, and therefore they're infinitely many solutions because they're going to intersect everywhere. So that's how you can use the combination method to solve for systems of equations. Okay? All right.